microbiome is basically a diversity of like fungi, virus, bacteria in your digestive tract. So usually during an early age, your gut microbiome is quite stable, and usually it will be affected in a later age if let's say you don't get insufficient sleep and you have a poor diet. And then funny enough, I find this research like a few days ago, which is done by Robert Koch and Louis. Yeah.
So let's look at the purpose of gut microbiota. Gut microbiota plays key roles in pathogen protection, immune training, metabolism, and vitamin synthesis. For the metabolic function, gut microbiota can acquire nutrients from food that trigger hunger, and it can break down compounds like cellulose that human intestines cannot break down on its own. They can also protect against pathogens like blastocysts by producing lactic acid and enhancing the gut's mucus lining, making it hard for the blastocysts to survive. They can also compete against other pathogenic strains for nutrients, making the pathogenic strains hard to survive in the human gut. They also synthesize some vitamins that we cannot extract from food, like the vitamin biotin, known as the beauty vitamin.
So for the types of microbiota we have in our system is the first one, bacteroides, where it will interact with the immune system, controls metabolism, and reduce inflammation and cancer risk. It also breaks down complex carbohydrates, which helps absorb nutrients and make short-chain fatty acids that are good and easily absorbed for our colon health. The next bacteria we're going to be talking about is Lactobacillus. It is a rod-shaped gram-positive and non-spore-forming bacteria that helps improve fermented foods, breaks down protein into helpful peptides. This also helps in digestion by breaking down food, especially lactose and complex carbohydrates. Not only that, this helps to enhance nutrient absorption, including vitamins and minerals.
Akkermansia mucinifera. It is a gram-negative, strictly anaerobic, non-spore-forming bacterium. Pasteurized A. mucinifera has been developed for the treatment of diabetes by improving glucose, lipids, and bile acids metabolism. The latest research shows that this bacterium also affects the host brain through the microbiota gut-brain axis, MGBA. Its metabolites can restore gut microbiota and repair the gut mucosal barrier. This can regulate the host immunity and neuroinflammation, and effectively alleviate the host's psychological disease such as depression, anxiety, and Alzheimer's disease. Bifidobacteria is a gram-positive, rod-shaped, strictly anaerobic bacterium that is beneficial to the human body and can be found in probiotics and yogurt. This bacterium not only plays an important role in regulating the function of intestinal microbiota, but in the latest research, this bacterium has also been found to have a great potential to improve cardiovascular disease. Its antioxidant properties can act on the oxidative stress of the heart, inhibit the catalytic effect of oxidation reactions by chelating ions, and improve cardiovascular disease.
As for application of gut microbiota, obesity disrupts gut microbiota, often increasing bacterial-AIDS ratio, which is considered one of the indicators of obesity. With Muribacula A, parts of bacterial AIDS, its abundance has shown correlation in reduced obesity risk, which improve inflammation and restore gut microbiota. Plant-derived components such as dietary fiber and pomegranate acid promotes Muribacula A growth, alleviating obesity symptoms by enhancing short-chain fatty acid production, increasing serum adiponectin, and reducing inflammatory markers like IL-17. Additionally, its decline in high-fat diets is associated with reduced levels of secretory IgA, acetic acid, and butyric acid, highlighting its role in maintaining immune and metabolic balance. Next, in type 2 diabetes, plant-derived dietary fiber like wakame and black seed polysaccharide improves glucose metabolism and insulin sensitivity by activating the pathway, which enhance insulin signaling, glucose uptake, and glycogen synthesis. These effects are linked to an increased abundance of Muribacula A, which influenced by acarbose treatment that helps in managing type 2 diabetes. Notably, Muribacula A plays a role in regulating gut microbiota composition, improving blood glucose metabolism, and organ damage. While more research is needed, this finding highlights its important function in maintaining glucose homeostasis and reducing type 2 diabetes-related complications. Last but not least, inflammatory bowel disease. In our stomach, the mucous barrier, primarily made up of mucin, which play a crucial role in protecting intestinal health, such as reducing mechanical stress, blocking pathogen, and maintaining immune balance. However, in IBD, damage to the mucous barrier results in increased permeability and inflammation. Microbiota A is essential for preserving barrier integrity as it produces short-chain fatty acid that promote mucin production, enhance anti-inflammatory response, and compete with the pathogen for space and nutrients within the mucous layer. Furthermore, a decrease in microbiota A levels disrupt this protective function, further weakening the mucous barrier. By overcoming this, plant-based interventions such as dietary fibers and polyphenol can restore the barrier function by increasing microbiota A abundance, boosting mucin production, and supporting SCFA-driven anti-inflammatory effects. Thus, strengthening this function is critical for repairing the mucous barrier and managing IBD.
So have you found out any implementation on this kind of technology?
Let me show you. So there's this thing called a gut on a chip system, which helps studying how gut bacteria affects depression along with other intestinal diseases. This system also aids in absorbing nutrients, supports immunity, and moving contacts with parasitic motion.
Thank you for explaining that. For our conclusions, for the first one we have vital roles. Gut microbiota regulates digestion, immunity, and metabolism. It also helps with the influences of obesity, diabetes, and inflammatory bowel disease risk. And lastly, personalized therapies and microbial diversity are key for our overall health. And if you have any questions, feel free to ask us. Thank you very much.